Hello everyone, welcome to this video on how Python works. Have you ever wondered what happens behind the scenes when you run a Python program? In this video, we'll break down the entire execution process step by step, from writing your code to generating the output. You'll learn about key stages like compilation, bytecode, and the role of the Python virtual machine. By the end, you'll have a clear understanding of Python's workflow and how it helps you write efficient and reliable programs. Let's get started. Introduction. Python is an interpreted language, meaning its code is executed line by line using the Python interpreter. This step-by-step execution makes it beginner-friendly and simplifies debugging. When you run a Python script, the interpreter converts the code into bytecode and intermediate format, which is then executed by the Python virtual machine PVM. This process ensures flexibility, platform independence, and ease of development. Understanding this workflow helps you write efficient, error-free programs while optimizing performance. It's a step-by-step process. 1. Source code. Python programs start with source code, which is written in plain text files and saved with the .py extension. These files contain the instructions you want the computer to execute, written in Python's simple and readable syntax. For example, a basic program like print hello world is written as a single line of code in a file. When saved with a .py extension such as hello.py, this file becomes a Python script that can be executed using the Python interpreter. The source code is the foundation of any Python program and represents the instructions that the interpreter will process and execute to produce the desired output. Writing clear and organized source code is essential for creating efficient and maintainable Python programs. 2. Python interpreter. When you run a Python program, the Python interpreter plays a crucial role in executing the code. It follows a systematic process to ensure your program runs correctly. The first step is lexical analysis, where the interpreter breaks the source code into tokens. Tokens are the smallest units of the code, such as keywords, identifiers, operators, and symbols, which help the interpreter understand the program structure. Next comes parsing, where the interpreter analyzes the sequence of tokens to build a syntax tree. The syntax tree represents the logical structure of the code and ensures that it follows Python's grammar rules. If there are any syntax errors, the interpreter will stop the execution and alert you. Once the syntax tree is built, the interpreter proceeds to compilation, where the syntax tree is translated into bytecode, an intermediate representation of the code. The bytecode is platform independent and is stored in .pyc files, typically found in the __pycache__ folder. This step prepares the code for efficient execution. Finally, the bytecode is passed to the Python virtual machine PVM for execution. The PVM processes the bytecode instructions one by one, performing the required operations to produce the final output. This multi-step process, lexical analysis, parsing, compilation, and execution, ensures that Python programs run smoothly and efficiently while also providing clear feedback in case of errors. 3. Bytecode compilation. Python does not execute the source code directly. Instead, it compiles the code into an intermediate format known as bytecode. Bytecode is a low-level, platform-independent representation of your Python code that acts as a bridge between the source code and the execution process. This compilation step ensures that Python programs can run consistently across different operating systems without requiring any modifications. Once the source code is translated into bytecode, the bytecode is stored in .pyc files, typically located in a folder named __pycache__. These files allow Python to skip the compilation step the next time the program is executed, improving performance by directly loading the precompiled bytecode. While bytecode is not human readable, it is an essential part of Python's execution process, enabling efficient and portable program execution. This step highlights Python's flexibility and its ability to balance ease of use with performance optimization. 4. Python Virtual Machine PVM. The Python Virtual Machine PVM is a crucial component of Python's execution process. It is a stack-based virtual machine responsible for executing the bytecode generated during the compilation step. Once the Python interpreter compiles the source code into bytecode, the PVM takes over and processes the instructions one at a time. Each instruction is fetched, interpreted, and executed in sequence, ensuring the program runs as intended. The PVM operates like a virtual CPU, performing the operations specified in the bytecode. It handles various tasks such as arithmetic calculations, data manipulation, and managing control structures like loops and conditionals. Since the PVM executes platform independent bytecode, Python programs can run seamlessly across different operating systems without needing platform specific adjustments. This step by step execution by the PVM ensures flexibility and reliability in running Python programs. By understanding the role of the PVM, developers can appreciate how Python translates human readable code into efficient, machine level instructions that deliver the desired output. Python execution flow. The execution flow of a Python program involves several distinct steps that transform human readable source code into the final output. First, the Python code is written and saved in a file with the .py extension. This file contains the instructions that define the program's functionality. When the program is run, the Python interpreter compiles the source code into an intermediate format known as bytecode. This step ensures that the code is optimized and ready for execution regardless of the platform being used. The compiled bytecode, which is stored in .pyc files within the _pycache_underscore folder, is then handed over to the Python virtual machine PVM. The PVM processes the bytecode instructions one by one, executing the required operations to produce the desired output. This process ensures that Python programs run efficiently and consistently across different systems. Python's dynamic nature. One of Python's key features is its dynamic typing, which simplifies coding by removing the need for explicit type declarations. In Python, you don't need to specify the type of a variable when creating it. Instead, the Python interpreter determines the type automatically at runtime based on the value assigned to the variable. For example, if you write x10, Python recognizes x as an integer. Later, if you reassign x hello, the interpreter dynamically changes the type of x to a string without requiring any additional steps from the programmer. This flexibility allows developers to focus more on solving problems rather than managing variable types, making Python highly user-friendly and efficient for rapid development. However, it also means that you need to be cautious when reassigning variables, as unexpected type changes can lead to errors if not handled properly. Python's dynamic nature is one of the reasons it's widely regarded as an intuitive and accessible programming language, especially for beginners. Interactive mode. Python offers an interactive mode that allows you to experiment with code in real time, making it an excellent tool for learning and testing. This mode is accessible through the Python shell, which can be launched directly from the terminal or within an integrated development environment that supports Python. In interactive mode, you can enter Python commands one at a time, and the interpreter executes them immediately, displaying the results instantly. For example, typing print interactive mode in the shell will directly output interactive mode on the screen. This feature is particularly useful for testing small code snippets, exploring Python's functionality, and debugging. You don't need to create a file or save your code. Instead, you can quickly try out ideas and see how Python behaves. Interactive mode provides a hands-on way to understand Python concepts and is a valuable resource for both beginners and experienced developers who want to experiment and refine their code. Practice example. To understand Python's workflow, let's write a simple program that calculates the square of a number. The program starts by prompting the user to input a number using the input function. Since the input function returns the input as a string, the program converts it into an integer using the int function. This ensures that the number can be used in mathematical operations. The value entered by the user is then stored in the variable num. Next, the program calculates the square of the input number using the exponentiation operator. This operator raises the number to the power of 2 and the result is stored in the variable square. Finally, the program uses a formatted string or f string to dynamically generate a message that displays the original number and its square. For example, if the user inputs 5, the program will calculate 5 2, resulting in 25, and output the message the square of 5 is 25. This simple program demonstrates the key steps in Python's workflow: accepting user input, processing data with mathematical operations, and displaying the result. It's an excellent example of how Python's features like dynamic typing and formatted strings make programming intuitive and efficient. Key takeaways. Python executes code in a systematic, step-by-step manner, starting with lexical analysis, where the source code is broken into tokens, followed by parsing, which organizes these tokens into a structured syntax tree. Next, the code undergoes compilation, where it is converted into bytecode, and finally, the bytecode is processed by the Python virtual machine PVM during execution. This structured flow ensures that Python programs are executed efficiently while providing clear feedback for errors. Understanding this execution flow is essential for writing effective programs. It helps you identify and debug issues, optimize performance, and improve the overall quality of your code. Python's clear and logical processing makes it easier for developers to pinpoint errors and refine their programs. To fully grasp these concepts, it's important to practice writing and running Python code regularly. Experimenting with different programs and observing how Python handles them in real time will deepen your understanding and help you become a more proficient programmer. That's it for this video on Python's execution flow. We explored how Python processes your code step by step from source code to output, and how understanding this workflow can help you debug and optimize your programs. If you found this explanation helpful, don't forget to subscribe, and hit the bell icon for more Python tutorials. Keep practicing, and I'll see you in the next video.